Aluminum expands and contracts at a different rate than cast iron. That is not a footnote. That is a design decision. And when an engineer ignores it, or gets forced to ignore it by a deadline, the two metals fight each other every single time the engine heats up and cools down. Eventually, something in the middle gives way. Ford has built some of the greatest V8 engines in American history. The Windsor, the Cleveland, the FE Big Block, the 429 and 460. Engines that raced at Le Mans, that hauled families across the country for 300,000 miles, that are still getting rebuilt in garages today because people trust them. But that is not the story we are telling right now. Today we are talking about the other side of the ledger. 3 engines Ford built, sold by the millions, and would probably rather you forgot existed. One of them got a bad reputation so toxic that Ford tried to quietly rename it out of that reputation. Stick around, because that one is coming. But real quick before we start, comment the classic car you want us to cover next. The comment with the most likes becomes our next video. Okay, let's get into it. In 1982, Ford introduced a new V6 for the Granada. 90-degree layout, cast iron block, cast iron heads, and a clever trick borrowed from Buick. Staggered crank pins. So instead of the lumpy, uneven firing pulses you'd expect from squeezing a V6 out of a V8 architecture, this engine fired evenly, smoothly, almost like an inline 6. Ford called it the Essex, and on paper, it looked like a smart piece of engineering. Modest early horsepower, somewhere around 110 to 115, fed by a 2-barrel carburetor. Nothing exciting yet. But it was compact, it was smooth for a V6, and Ford started dropping it into everything. The Granada got it first, then the Thunderbird, then the Mustang, then, years later, the Windsor minivan. This was not a niche engine tucked into one obscure trim level. This was a workhorse Ford leaned on for 2 decades, across some of its best-selling cars in America. If you bought a Ford or Mercury sedan, coupe, or minivan through the 80s and 90s and didn't spring for the V8, there is a very good chance the Essex was sitting under your hood, quietly doing the work millions of American commutes depended on. And for the most part, buyers liked it. It was smooth. It idled quietly for a V6 of that era. It gave Ford a middle ground option between an economy 4-cylinder and a thirstier V8, at a time when fuel prices and insurance costs were pushing a lot of American families away from big blocks. General Motors had its own version of the same idea, the 3 8-liter Buick 5.6, and for years, the two engines competed quietly against each other in showrooms without either one becoming a headline. The Essex might have stayed exactly that, a forgettable, competent, mid-tier engine, if not for what started happening to it around the late 1980s. And for a while, that early carburetor was actually its own small headache. Ford used something called a variable Venturi carburetor on those first Essex engines, a design that opened a small air passage at low speed for a cleaner fuel mixture, then widened dramatically at full throttle for maximum airflow. It's the same basic philosophy General Motors used with their Quadrajet, small primary barrels, big secondary barrels. The idea was sound. The execution, in Ford's case, was finicky enough that it could have been its own video on its own. But that carburetor trouble was nothing compared to what was coming for this engine's reputation. Because underneath that smooth, even firing V6, the Essex had a problem baked into its bones: head gaskets. Chronic, relentless, almost engine-wide head gasket failures. Before I show you exactly how that failure happens, let's pause for 1 second. Quick thing before we carry on. If you own a classic car, or you're thinking about buying one, I made something for you. It's a 50-page guide called Know What It's Worth. Here's what it does. It teaches you how to check a car yourself. The numbers stamped on the body, the engine, the tags under the hood, and find out 2 things: whether it's the real thing or a fake, and what it's honestly worth today. Takes about 20 minutes with a flashlight. You don't need to be a mechanic. It's at classiccarshistory.com. The link is in the video description. Alright, back to it. Here's what was actually happening. The Essex used an aluminum intake, but more importantly, the thermal behavior of the head-to-block interface, combined with narrow gasket material right next to the combustion seal on certain cylinders, meant coolant could slowly wick its way into the edge of the gasket over time. Not all at once, slowly, degrading it from the inside, cylinder by cylinder, year after year, until one day the gasket simply gave up and let coolant into a cylinder it was never supposed to touch. Owners would see white smoke rolling out of the tailpipe. They'd check the coolant reservoir and find it mysteriously low. Again, for the third time that year, some would notice a sweet smell coming from the engine bay that had no business being there. It got worse before it got better, too. In the late 1980s, Ford introduced a supercharged version of the Essex for the Thunderbird Turbo Coupe successor, badged as the Thunderbird Super Coupe. Bolting a supercharger onto an engine that already struggled to keep coolant on the correct side of its head gaskets was not exactly a recipe for improvement. Higher cylinder pressures meant more stress, right at the exact seam that was already the engine's weak point, and owners of the supercharged cars tended to report head gasket trouble even more often, and often earlier in the car's life, than owners of the naturally aspirated version. A performance upgrade that, on paper, should have made the Thunderbird more exciting, ended up making its most persistent mechanical flaw even more persistent. Owners learned to recognize the pattern almost by heart. It usually started small. A little extra coolant loss between fill-ups that couldn't be explained by any visible puddle in the driveway. Then a faint, sweet smell drifting out of the vents on a cold start. Then, if it went unaddressed, white smoke from the tailpipe that thickened as the engine warmed up, and a rough idle as coolant found its way into a cylinder or two and fouled the spark plugs on that side of the engine. Mechanics who specialized in these engines got so used to the pattern that some could diagnose a failing head gasket over the phone, just from an owner describing the smell. This wasn't a rumor. This wasn't internet folklore blown out of proportion. Ford itself sent dealers a technical service bulletin in 1998, numbered 98-4-9, warning that premature head gasket failure could lead to complete engine failure on front-wheel drive Essex applications, built between 1988 and 1995. That covers the Taurus, the Sable, the Continental, the Windsor, millions of cars. Ford even extended a limited warranty program to cover some of those repairs, 5 years or 60,000 miles for the newer ones. But here's the catch that made owners furious. Consumer advocates pointed out that a huge chunk of the failures, something like 40% by their tracking, showed up between 60,000 and 75,000 miles, right outside the window Ford was willing to pay for. Ford tried to fix it. New head gasket material, revised bolt specifications. Some improvement came in the 1990s, when the engine picked up sequential port fuel injection instead of that troublesome carburetor. And there is a genuine fair point to make here. Later versions, especially post-1999, redesigns and the versions built after 2000 cleaned up a meaningful amount of the head gasket problem. But by then, the damage to the Essex name was done. Ask anyone who drove a Taurus, a Sable, a Windsor, or a Mustang with the 6-cylinder option through the 80s and 90s, and the phrase, "the head gaskets go on that thing," comes out almost automatically. It became a permanent asterisk next to the engine's name. And that brings us to the part of this story that Ford probably really did not want you to notice. By the time the 2000s rolled around, Ford had quietly stretched the Essex's displacement, first to 3.9 liters, later stroked further to 4.2. Officially, Ford framed this as a natural evolution, more displacement, more torque, a refined engine for the modern lineup. Unofficially, plenty of longtime Ford technicians and enthusiast forums noticed something else. The 3.8 badge, the actual number stamped in people's memories as the head gasket engine, quietly disappeared from Ford showrooms. Owners on enthusiast forums pieced it together themselves in real time, comparing notes on when Mustang V6 models switched from being labeled 3.8 to 3.9, and noting that the timing lined up suspiciously well with a company trying to put daylight between a new engine and an old reputation. Nobody at Ford ever stood up and said, "We're renaming this so people forget about the head gaskets." But a badge change that happens to erase the exact number associated with 2 decades of warranty claims is the kind of coincidence that doesn't need a press release to make its point. So that's engine number 1. Smooth firing, Reasonably efficient, genuinely clever staggered crank engineering, undone by a head gasket problem so persistent that Ford eventually tried to outrun its own nameplate. Let's move to something much bigger, much more expensive, and honestly, much worse. If you ask serious Ford diesel owners what the single worst engine the company ever put its name on was, you will hear one answer over and over. The 6-liter Power Stroke, built from 2003 through 2007, dropped into Super Duty pickups, the Excursion, and E-Series vans. This engine arrived with an enormous amount of pressure riding on it, because of what it was replacing. The engine before it, the 7.3-liter Power Stroke, built by Navistar, was one of the most beloved diesel engines in American history. It was in school buses. It was in fleet trucks that racked up 500,000 miles. It had a reputation for basically running forever if you changed the oil. Ford didn't retire it because it was unreliable. They retired it because of noise. New emissions and noise pollution regulations, particularly in California, were closing in on diesel engines, and the 7.3's mechanical clatter, the sound everyone associated with a real diesel, was becoming a compliance problem, not a performance one. So Ford and Navistar built something new, quieter, more refined, more powerful on paper, with 325 horsepower and roughly 570 pound-feet of torque, numbers that actually beat the diesel competition from Dodge and General Motors at the time. On paper, the engineering choices looked sound: a cast-iron block, cast-iron heads with 4 valves per cylinder, a bedplate-style bottom end that most mechanics agree was genuinely tough, forged steel connecting rods that could handle real abuse. Compared to the Dodge Ram's 5.9-liter Cummins, rated at around 460 pound-feet of torque at the time, and General Motors' Duramax, which fell short of the new Power Stroke's numbers as well, Ford's new diesel looked like the class leader. 19 miles per gallon on the highway from a heavy-duty pickup was, for 2003, genuinely impressive. Buyers walked into Ford dealerships expecting an upgrade in every direction. And then owners started driving them. The failures didn't come from one single bad part. They came from a chain reaction, one flaw setting off the next, like dominoes falling in a very specific, very expensive order. It starts with the oil cooler. Inside the 6-liter, the oil cooler has narrow internal coolant passages, and those passages clog. Sometimes it's leftover casting sand from the manufacturing process that never fully cleared the block. Sometimes it's mineral deposits building up from old coolant that wasn't serviced on schedule. Either way, once those passages clog, the oil cooler stops doing its job efficiently. Here's where it gets vicious. In this engine's design, coolant flows from the oil cooler directly into the EGR cooler, the component responsible for cooling exhaust gas before it's recirculated back into the intake. A clogged oil cooler starves the EGR cooler of the coolant flow it needs. Starved of proper cooling, the EGR cooler overheats and, over time, cracks or ruptures internally. And once that happens, coolant starts leaking directly into the engine's intake and combustion chambers, right alongside the exhaust gas that's supposed to be there. An engine cannot compress liquid coolant the way it compresses air and fuel. Liquid doesn't compress, so when that coolant gets pulled into a cylinder during the compression stroke, pressure spikes violently in a way the head gasket was never designed to survive. That's the final domino. Blown head gaskets. On an engine where replacing them means pulling the cab off the frame on some Super Duty configurations, because that's literally how you access the engine. Owners would watch coolant get forced out of the degas bottle under load. White smoke that smelled sweet, not like burning oil. A check engine light for cylinder misfire that had nothing to do with the ignition system and everything to do with coolant sitting where fuel should be. The community response to all of this became almost a movement of its own. Search online today, and you will find entire forums built around one phrase: bulletproofing the 6-liter Power Stroke. Heavy-duty head studs to clamp the heads down harder than factory, upgraded oil coolers with wider passages that resist clogging, upgraded EGR coolers built with sturdier internals. An entire aftermarket industry grew up specifically to fix a design Ford shipped from the factory. And the cooling chain wasn't even the only place this engine could bite an owner. The fuel injectors on the 6-liter are oil-actuated, meaning they rely on precisely controlled oil pressure to fire correctly, rather than a purely electronic signal. Owners started noticing a condition, mechanics nicknamed stiction, where the injector spool valves would get gummy and hesitant, especially on cold starts, causing rough idling and random cylinder misfires that could take hours to properly diagnose. Feeding those injectors is a high-pressure oil pump, and that pump depends on a fuel injection control module, the FICM, to deliver stable voltage. When the FICM's internal capacitors degraded, voltage would sag, injectors would fire late or not at all, and a perfectly healthy engine could suddenly feel like it was running on 5 cylinders instead of 8. Layer on a variable geometry turbocharger prone to sticking from carbon buildup, and an EGR valve that clogged with soot quickly enough that some owners were told to clean it at every other oil change just to keep the truck drivable. And you start to understand why 6-liter ownership became less about driving a truck and more about managing a checklist of systems that all seem to be working against each other. It's worth noting, too, that later production years brought some quiet improvements. The 2003 model year, for instance, used a round EGR cooler that held up noticeably better than the less efficient square design Ford switched to for 2004 through 2007, a small design regression that made the very trucks most people associate with the 6-liter's worst years slightly more failure-prone than the first ones off the line. To be fair to Ford, the 6.4-liter Power Stroke that replaced this engine in 2008 addressed some, though not all, of these weaknesses. But for the 4 model years the 6-liter was on sale as delivered, the honest advice from most diesel mechanics, then and now, is simple. Stay away from a stock, unmodified one, or budget immediately for the bulletproofing parts the day you buy it. That's engine number 2. Quieter than what it replaced, more powerful on the spec sheet, and undone by a design flaw so mechanically elegant in its cruelty that it reads almost like a lesson in cause and effect. Clog leads to starvation. Starvation leads to overheating. Overheating leads to a ruptured cooler. And a ruptured cooler leads to an engine trying to compress a liquid, which no engine on Earth can survive doing for long. One more engine to go, and this one might be the most quietly frustrating of the 3, because unlike the other 2, this one didn't have to fail. It failed because of a maintenance schedule Ford printed on the dashboard that turned out to be dangerously optimistic. The Modular V8 family is actually one of Ford's genuine long-term success stories. The 4.6-liter version of this engine family, in its 2-valve configuration, became a favorite of taxi fleets and police departments across the country, routinely running past 400,000 miles with basic maintenance. That's the reputation this family built for itself, which makes what happened with the 5.4-liter 3-valve version, built from 2004 through 2008, even more disappointing, because it's the same extended family, gone wrong in a very specific, very avoidable way. Start with the spark plugs, because this is the detail people remember first, and for good reason. The 3-valve 5.4 used a 2-piece spark plug design, seated in the aluminum cylinder head. If a plug wasn't torqued to the exact factory specification, or if the threads in the aluminum head had worn even slightly from a previous plug change, the plug could work itself loose under the pressure of combustion, not just loosen, physically eject. Get blown clean out of the cylinder head while the engine was running, sometimes taking a chunk of the surrounding threads with it. Technicians who worked on these engines regularly will tell you a spark plug change on this engine required patience, and a delicate touch that a lot of quick lube shops simply didn't have the training or the time to apply. Ford eventually revised the cylinder head design partway through the 2008 model year, specifically to fix this. But the spark plug problem, expensive and dramatic as it was, wasn't actually the engine's deepest flaw. The deeper problem was sludge. The 3-valve 5.4 introduced variable cam timing, a system that uses engine oil pressure, precisely controlled, to physically rotate the camshaft phasers and adjust valve timing on the fly, for better power and efficiency. It's a genuinely clever piece of engineering. But it depends entirely on clean oil moving through very small passages at the correct pressure. Skip oil changes, or stretch them out to whatever interval feels convenient, and sludge starts building in the upper end of the engine. That sludge doesn't just sit there being gross. It actively clogs those already narrow oil passages feeding the cam phasers. Once the phasers are starved of proper oil pressure, you get a distinctive rattling, almost diesel-like knocking sound at startup, as the phasers struggle to hold their position. Left unaddressed, worn phasers can lead to timing chain and guide wear, and in the worst cases, valve timing errors severe enough to let a valve contact a piston. The scale of the problem is honestly a little staggering when you look at how many times Ford went back to the drawing board on this one part. Engineers revised the cam phaser design roughly 40 separate times over the course of this engine's production run, each revision trying to solve chattering, wear, or leaking that the previous version hadn't fully fixed. Compounding the issue, the timing chain guides on this generation of engine were made from a nylon composite rather than metal, and once they were starved of oil, that plastic wore down quickly, sending small fragments of debris into the oil pickup and the pan, which then threatened to clog the very passages the phasers depended on in the first place. It's a self-reinforcing cycle. Sludge starves the phasers. Worn phasers stress the guides. Worn guides shed plastic. Plastic clogs the passages further. And the whole cycle accelerates every mile the truck goes, without a fresh oil change. Here's the part that made this problem so brutally expensive for owners. Once sludge has caused actual wear damage inside that top end, simply swapping in new cam phasers and rocker components doesn't fix it. The oil pressure problem underneath is still there. The noise comes back. The wear continues. In a lot of documented cases, the only real fix at that point was a full engine replacement, not a repair. The maintenance recommendation that circulated among mechanics who actually understood this engine was blunt. Forget the 7,000-mile interval flashing on the dashboard computer. Change the oil every 3,000 to 4,000 miles, especially if the truck saw a lot of idling, towing, or stop-and-go driving, and use it religiously. Owners who followed that advice tended to rack up big miles without drama. Owners who trusted the factory prompt on the dash sometimes found themselves shopping for a new engine well before 200,000 miles. It's a strange kind of failure, honestly, because unlike the Essex's baked-in metallurgy problem, or the 6 liters cascading cooler design flaw, this one really was preventable, with information the average owner simply didn't have. Now, before we wrap this up, a couple of near misses worth a quick mention, because they almost made this list too. The 2.3-liter 4-cylinder, especially in its turbocharged form, used in the Mustang SVO and the Merkur XR4 Ti, developed its own reputation for head gasket trouble, similar in spirit to the Essex, if smaller in scale and lower in production numbers. It was a genuinely quick, interesting little engine for its era, but the same story of aluminum meeting cast iron under thermal stress showed up in miniature, and it never quite escaped that shadow the way its bigger V8 cousins eventually did. And going back a bit further, the 351M and the 400 V8s from the mid-1970s deserve an honorable mention for very different reasons. Both suffered from relatively weak bottom ends prone to losing oil pressure under sustained load, and the 400 in particular dealt with casting porosity issues that could let oil seep through the block itself in some examples, a defect with no real fix short of replacement. The 351M specifically was so strangled by lean, emissions-era carburetor jetting in full-size cars that it felt genuinely underpowered, driving something like an LTD Brougham, even though the displacement on paper suggested otherwise. Owners who understood carburetors could sometimes claw back real drivability by richening the jetting in small increments, just a few thousandths of an inch at a time. But that was a fix most dealerships never bothered offering, and most drivers never knew was possible. Worth remembering, too, that Ford, in that same era, was simultaneously building 3 completely different engines that all happened to share the number 351, Windsor, Cleveland, and Modified. 3 unrelated designs, different blocks, different heads, different architectures entirely, wearing the same displacement badge on the outside, which tells you a lot about how confusing Ford's own engine lineup could get even internally, let alone for the average buyer standing on a dealership lot trying to make sense of an option sheet. So where does that leave Ford's overall track record? Compared to General Motors' worst offenders in the same era, Ford actually comes out looking relatively disciplined. Ford's problems tend to be middling rather than catastrophic. Solid, reliable core designs undone by one weak component, a head gasket, an oil cooler, a spark plug seat, rather than an engine that was rotten from the block up. General Motors, by most enthusiast and mechanic accounts, has a wider spread. Their best engines edge out Ford's best, but their worst engines dip lower than anything on this list. That's a story for another video entirely. What ties these three Ford engines together isn't incompetence. It's the gap between an engine that works fine on a test bench and an engine that has to survive 15 years of real drivers skipping oil changes, driving through Minnesota winters, and towing boats they probably shouldn't be towing. The Essex was a smart, smooth-running design, let down by a narrow strip of gasket material that couldn't handle years of thermal cycling. The 6-liter Power Stroke was a genuinely more refined diesel, undone by an internal cooling passage nobody anticipated would clog so easily. And the 3-valve 5.4 was a clever variable timing system that simply demanded more discipline from owners than the factory maintenance schedule ever asked for. 3 engines, millions of vehicles. And in at least one case, a company quiet enough about its own mistake that it just changed the number on the valve cover and hoped everyone would move on. None of this erases what Ford got right elsewhere. The same company that let the Essex bleed coolant for 2 decades also built the FE Big Block that powered Le Mans' winning GT40s. The same company that shipped a 6-liter diesel with a cooling system fighting itself also built the 7.3 that owners still swear by today, and the 4.62-valve Modular V8 that taxi fleets ran into the ground without complaint. That's really the honest takeaway here. Even a manufacturer with a genuinely strong engineering reputation ships engines it would rather not talk about, and the difference between a great automaker and a mediocre one usually isn't whether mistakes happen. It's how narrow those mistakes stay, and whether the company is willing to actually fix them once real owners start reporting real problems, rather than quietly hoping a new number on the valve cover makes people forget. For every Essex leaking coolant into a cylinder, there was a Windsor running strong past 200,000 miles in the same decade, in the same showroom, sometimes in the very same model. One last thing before we finish, and it's the important one. I made a 50-page guide called Know What It's Worth. If you own a classic, or you want to, this is the one thing I'd put in your hands. It teaches you to check a car yourself, where the numbers are stamped, what they mean, and how to tell when somebody's changed them. 20 minutes with a flashlight, and you know whether you're looking at the real thing or a very good story. Then it tells you what to do about it. How to buy one without paying real car money for a fake. How to sell one without losing a third of it in fees. And how to write it all down in one folder. So if the day comes when you're not here, your wife or your son doesn't sell that car to the first stranger with a trailer for a fraction of what it's worth. 50 pages, big print, made to be printed out and kept with the car. It's at classiccarshistory.com. Link is in the video description. Thanks for watching. See you in the next one.